Hello and welcome to the second week of our full stack tutorial series where we are building a clone of the intercom support chat that is called Freecom. If you remember where we left off last week, that was right after we created our own GraphQL backend. And we also sent one mutation in a playground to create a new customer that is called Cool Tomato. Today we're actually going to start and write some code. So we're starting out with a React application and we want to integrate the Apollo client to interface with the GraphQL API. The way this is going to work, and also in the upcoming weeks, is that we prepare a starter project each week. So if you actually want to code along, you can head over to this GitHub repository and download the starter project for the respective chapter. So this is the starter project for the second chapter that we're going to use today. And then we also include a final project so that if you get lost along the way, you definitely have a reference solution that you can look at with all the functionality that we wanted to implement today. All right, so before we go and dive into the actual application, let me present to you what kind of components we're going to use, because all these components are already prepared in the starter project. So I've prepared a couple of slides here. So let's start with the first one. Here we see what the final application is going to look like. On the left, we've got a list of conversations, and then on the right-hand side, we've got an actual chat window. So let's take a look at what kind of React components we're going to use in order to build this application. So first of all, we render everything in an app component. So that's kind of the root component of our application. And then for the conversation list, on the one hand, we've got the conversation list header, then the conversations list component, where we render all the individual conversation items. So this is the basic structure, the basic component structure for the conversations list. Let's now take a look at the actual chat window. So in the chat window, we also have a header. It's called the chat header component, and it potentially also renders a back button and the profile picture of the agent that the user is chatting with right now. Then we have the chat messages component, and in there we render each individual chat message. And then on the bottom, we've got the chat input component. So these are all the components that we're going to use in our application. And in the next part of this video, I'm going to show you what these components look like in code. All right, so next we want to go and explore the starter project. So head over to the GitHub repository and download the Freecom-02 directory. I already downloaded it and have it open right here in my IDE. And notice that we initially created this project using create React app. So this index.js file, as well as the app.js component, they were generated for us initially. In the index.js file, we only made a few minor adjustments so that we can actually go and render our application into an existing website. And then we also have this configuration object that you can use to choose your own company name, company logo, and a main color for the application. Then we also already included all the components that we saw before on the slides. So we've got the app component, then we've got the conversations list, the conversation list header, and the conversation items. And then we've got also the chat header component, the chat messages, and the chat message itself. And finally, of course, the chat input. So these are all the components that we saw before on the slide. And each component also has a corresponding CSS file where we store the styles for each component. All right, so let's take a look at the app.js component, because that's the root component where we are going to put most of the logic. The app.js component basically has two different states, depending on whether the user has a conversation selected or not. So if there is no conversation selected, then we're going to render the whole conversation list. Once the user selects a conversation, then we are going to render a chat window for that specific conversation. Let me now quickly walk you through the major behavior of the app component. So when the component loads initially, we're actually going to check in local storage whether we already have information about an existing customer. If that's the case, then we're going to load all the conversations for that particular customer, or otherwise we're going to create a new one. So we basically have 4 methods in the app component that we're implementing today to get that kind of functionality and set it up and connect it with our GraphQL server. So we've got the setup new customer method where we're going to create a new customer. In load conversations, we're going to request all the conversations from the backend. Initiate new conversation is going to start the process of creating a new conversation for the customer, and then create new conversation is actually going to create the conversation on the GraphQL server. So these are the 4 methods that we're going to implement in the app component. And before we start with the implementation, we actually need to add a couple of dependencies to our project. So let me head over to a terminal where I'm currently in the root directory of the project. So here we've got the package.json file, and now we have to add 3 dependencies to the project. And these dependencies are the Apollo client package that contains the major functionality of the Apollo client in general. Then React Apollo contains the bindings for React and Apollo, and the GraphQL tag library contains some functionality for parsing queries and mutations. So I simply hit enter to install these dependencies, and once they're installed, we can go and set up the Apollo client in our index.js file. So while this is loading, I'll already go back to the IDE and open index.js, where we are going to set up the Apollo client. And the first 2 things that we have to do is to implement, to import the Apollo client and the Apollo provider components from the respective packages. The Apollo client is going to be our main interface to the GraphQL server, and the Apollo provider will be the component that we wrap around our app component so that all our components in the component hierarchy get access to the functionality of Apollo. What we have to do then is that we have to instantiate the Apollo client using a network interface. And the network interface we can create using the createNetworkInterface function right here. And what we have to do when we're using this function is that we're passing in the URL of the GraphQL endpoint. So if you've lost your GraphQL endpoint at this point and you're not quite sure what it was, you can always go back to the GraphQL console, select your project here in the project selection, and then in the bottom left, you've got this endpoints button that you can simply click to find out what your endpoint for this GraphQL project was. So I'll copy it over and paste it as a URL to the createNetworkInterface function. So now we can use this network interface to instantiate our Apollo client. And now this Apollo client is going to be associated or connected to our GraphQL backend. Next, I'm using the Apollo provider, as promised before, to wrap our app component, and then the Apollo provider also gets as a prop the client that we instantiated above. Great. So this is all we have to do to configure our application to use Apollo. And in the next part of this video, we are going to see how we can send queries and mutations using the Apollo client right here, and more techniques that the Apollo generally offers. So now we are starting to implement the actual functionality of our application. And the first thing that we're going to build is the ability to create a new customer in the backend. By the way, if you want to run the app, you can always go into a terminal and type npm start, And then you can see the current state of the application by opening a browser and navigating to localhost on the port 3000. And then that's going to render the button that we can use to open and to close the actual Freecom support chat on the bottom right. So this is what our application looks like at the moment. However, we can't really interact with it yet because we haven't built any functionality. So the first thing we want to do is to create a new customer. And that happens automatically when a new user opens the app for the first time. We're going to randomly generate a username for them and use that username to send a mutation to the GraphQL server. Now we want to implement our very first mutation to create a new customer in the database. So for that, we first have to import the GQL function that we get from the GraphQL tag library that we just added to the project before. And then next, we actually have to create the mutation. And the mutation that we're going to create looks as follows. So we're creating a new JavaScript variable that is going to represent the mutation and that we're using we are giving it to our app component so that in the app component we can access this mutation functionality. We'll see what that looks like in a second. So inside here we're passing the name as an argument so that we know what's the name of the customer that we're about to create. And right here we're using the same mutation that we already used in the playground. We're passing in the name as an argument, the name that we received from the create customer mutation. And then what we're also doing is we're creating an initial conversation. So this is actually a nested mutation where we're not only creating a new customer, but we're also creating a new conversation right away. And the way how we do this is by simply specifying the conversations array, so the list of conversations that each customer is associated to, with a new conversation that has the Slack channel index 1 because it's the first conversation of that customer. And right here we simply specify the payload, so all the information that we want to get back after this mutation has been performed. Next, we want to make the functionality of this mutation available to the app component. And the way how we do this is by using a higher order component called GraphQL from the React Apollo package. So let's first go ahead and import that one. And then we need to use this function in order to combine the mutation with the app component. And we're going to do that at the bottom right here. So we're using the GraphQL function, then we're passing in the create customer and conversation mutation as the first argument. As the second argument, we can specify what the mutation function that is going to be injected into the props should be called. So we're going to call it create customer and first conversation mutation. And then we're passing the app. So this is going to have as an effect that the app component gets this function injected into its props and we can use it to send a mutation to the backend. Now the last thing that we've left to do is to export the result of that function call rather than the default app component right here. All right, so now if we run the app, we will see that we've got the functionality available to create a new customer in the backend. So next we can go and start implementing the create or the setup new customer method right here. This is what the implementation of the method looks like. So we first generate the short stupid name that is based on, or it's just a random name that we're generating from a npm package called silly name. So you can actually take a look at it here. And then we're using the create customer and first conversation mutation in the props of the component. So this is exactly what I was talking about before, that this mutation is now available in the props as a function where we only have to pass in the variables that we want to use for that particular mutation. So here we're passing in the name that we just randomly generated. The result will be everything that the server returns. So this is going to be the huge data object that carries all this information that we specified in the payload right here. So this is the result object. So we can use it to retrieve the ID of the newly created customer, and then we'll actually go ahead and store that information in local storage. And finally, we are setting the conversations list in the state and also the selected conversation ID, so that by default, each new customer will have or will see a chat window rather than an empty list of conversations, so that they don't have the work to create a new conversation initially, but they are presented with an already open chat window. Okay then, let's see if the functionality actually works and if the new customer and the conversation are created when we reload the app. So I'll navigate over to a browser and refresh the page. We don't really see anything happening right here, but if we go to the data browser and we check the data in the database, then we'll see that we have a new customer and a new conversation that have been created. So Amberwing Dragon in this case is the randomly generated name. And then we also see that the nested mutation worked. So we not only created the customer, but right away we also created this conversation that we also can take a look at right here. So that functionality works. We can now move on to the next part, where we are going to load conversations for existing customers. And by the way, only to validate that what I told you before is also true, that when we click on the little button right here and open the application now, we're simply presented with a chat window because the conversation ID has been set automatically on the app state, on the state of the app component. Okay, let's move on then to load all the conversations for a specific customer when they reopen the app, but they already exist in the database. The first thing that we have to do to implement this method is to create the query where we're asking for all the conversations for our current customer. And this is what this query looks like. So we're passing in a customer ID and using this customer ID as a filter to only retrieve those conversations where our current customer is involved. And then we're also again specifying the payload for the query. So this is all the information that we want to have returned for each conversation. And notice that we're also asking for the last message that was sent in that conversation, so that we can display that as a preview in the conversations list. We now would have two different approaches how we can use this query and fetch the data from the server. And the first approach would be to use the GraphQL higher order component again. So we could actually go down here and simply wrap the component again with the query, and this would make the data available in the props of the component. But for now, we are actually choosing a different approach, and that is we want to send the query directly using the Apollo client. And we can make sure that the Apollo client is available in the component by wrapping it with the with Apollo function. And we will also have to import this function from the React Apollo package. So right here we can go and import with Apollo. All right, so now Apollo is going to inject a prop called client, and that client will have a function that we can use to send a query. So this is what the implementation of load conversations looks like. So this is what the implementation of the load conversations method looks like. So the first thing that we do is we are sending a query using the injected client prop. And we simply pass the find conversations query that we defined above, as well as the customer ID as a variable to the call to the query method on the client. Then we're going to sort the conversations that we receive from the server. And then we decide whether we are going to display an empty conversation to the user. So that's the kind of functionality that I mentioned before, that if we know that the user currently only has one conversations or only has one conversation, and in this conversation we have 0 messages at the moment, we can be sure that this was like the initial creation of the user. So we want to actually display an empty chat window to the user so that they can get started with their support questions right away. So this is what we're implementing here. And simply to make sure that this is working so far, let's actually go ahead and add a log statement and then run the application to see what we are getting back from the server. So here I'll simply print the sorted conversations, and we want to convince ourselves that for the one user we are seeing the conversation being printed, but we still expect the empty chat window to display right away. So let's go to the browser, refresh the page. And here we see that the array that contains one conversation is being printed. It has 0 messages at the moment, and if we actually open the application like this, then we see that we are ending up directly in the chat window and not in the conversations list, because that's what we implemented right here. All right, so the next step is going to be to implement the initiate new conversation method. And in here, we're actually only preparing or checking whether we should actually create a new conversation. This is what the implementation looks like. So we first grab the customer ID and the username from local storage. And then we actually check if that user already has an empty conversation that we currently have stored in the state of the component. Because if that's the case, we don't want to go and create a new conversation in the backend, because that would mean that if the user presses the new conversation button, often one time after another, that we would create a new conversation each time. Instead of doing that, we implement this protection mechanism to make sure that we can only ever have one empty conversation per user. And if that's the case, then we'll simply use that empty conversation and display it in the chat window. But if that's not the case, then we can go and create the new conversation. And here again, we're following a very similar workflow as we had with our very first mutation. So we first have to go and create a new conversation that allows us to create a new conversation in the backend. And this mutation looks like this. So we're adding it to the top of our file again. And it's called CreateConversation Mutation. We can test this functionality if we simply go to a browser again and reload the page. But we're actually not going to see a lot this time. So similar to the mutation that we saw before, we have to use the GraphQL higher order component again to wrap our component with the mutation that we just created to make the functionality of this mutation available to the component. However, we are already wrapping the app component with the create customer and first conversation mutation. So now we have to add a second mutation to that. And the easiest way to do so is by using the compose function that you can also import from the React Apollo package. We just import it like this, and then we're scrolling down again and adjusting our export statement to look like this. So we're using the compose function where we're passing in the first mutation to create a conversation, and then the second one, the create customer and first conversation mutation. So we are wrapping both of them into the app component, and then we're again using with Apollo on the result, which is called app with mutations right here. So this is what we have to do to get the functionality of our second mutation into the app component. Let's now go ahead and actually implement the CreateConversation method where we are using that functionality. So here is what the implementation looks like again. First, we have to figure out what the current index or what the index of the Slack channel for that conversation should be. And we can simply calculate that by extracting all the channel positions of all the previous conversations and then adding one so that we know which is the new Slack channel index for that new conversation. Then we are just using the CreateConversation mutation that we now have access to because we wrapped it with the GraphQL component. And we're passing as arguments the ID of the customer as well as the channel position that we calculated right here. And then we get back the result with the conversation ID, and we're taking that conversation ID to set it right away so that we're displaying the chat window for the new conversation when that happens. Let's go and test our implementation so far. So just simply save the file and then navigate to a browser again and refresh the page. If you do that, you'll see that you're still only presented with the empty chat window. And we can't really do anything against that. So we can type and we hit enter, but we know that no messages are sent yet because we haven't implemented that functionality. And the reason why we don't see the conversation list is because we said before that every new user who doesn't have any messages in their first conversations yet, they should just see the empty chat window. So let's actually go and create a fake message in the GraphQL console so that we see if the functionality that we implemented so far actually works. So right here, I'll just select the message type in the data browser. And I can simply go ahead and create a new message right here. I'm typing a text. And then I also have to associate this message with the only conversation that we have in the database so far. And if I do that and go back to the browser, refresh the page and open the app again, then we actually see the conversation list for the first time, and we also see the last message as a preview on the conversation item. And as we can see here, we can also move back and forth between the conversation list and the actual chat window. However, the chat is not really working yet. So if we wanted to write a message right here, we of course can send it. And likewise, the message that we just created and that is available in, or that we can see in the data browser, is also not being rendered on the screen just yet. So let's actually go ahead and implement the chat functionality next. Let's go back to the IDE and open the chat component where we are going to implement the first thing, and that's the all messages query. So we want to query all the messages for that particular conversation that the user selected. So the way how this is going to work is by first, again, creating the all messages query. And then we want to wrap this query again using the GraphQL higher order component to make the result of the query available to the chat component. Let's therefore first implement or import the GraphQL function, the GraphQL higher order component from the React Apollo package, and then use that function to wrap our component with the all messages query. So again, at the bottom of the file, we're using the GraphQL function, passing in the all messages query from above, and we're giving it the name all messages query. So this is going to be the name of the injected variable of the injected object in the props of our component. So we are wrapping the chat component with this, and we also have to adjust the export statement. So rather than exporting the class up here, we're exporting the result of our call to GraphQL. Okay, so the result of this is now going to be that we have a new prop inside our chat component available that is called allMessagesQuery. And this query actually carries 3 different properties that we can use in order to render the UI. So the first one is a loading property. And we can use this property to display a potential loading state to our users. So this is what it looks like. We access the allMessagesQuery prop that gets injected, and we check if that query is currently loading. If that's the case, then we will simply return the loading container that we've set up before. Or otherwise, in case we actually receive some data and we have the messages available that we receive from that query, we can go and render that information right here in the render method. allMessagesQuery. And this will carry the allMessages field. And if that's not available, we want to make sure that we don't get an undefined error and just simply pass an empty array. All right, so with this code in place, we should already see the message being rendered on the screen if we run the browser again. Oh, and of course, we also have to import the GQL function because we're using GQL right here. So let's do that real quick. Copy it over from the app component. There you go, save the file, refresh the browser. And if we now go into the chat, we saw the loading indicator for just a little while and then the chat message being rendered on the screen. One thing that we actually haven't talked about is how the allMessagesQuery knows which conversation it should fetch the messages for. So if we recall how we send the allConversations query in the app component, here we called the query method on the Apollo client, and we simply passed in the variable as an argument to that call. However, in the chat component, we're using the GraphQL higher order component to wrap our chat component with the allMessagesQuery down here. So we don't have the ability to manually pass in any variables to this call. The way how this works is that actually under the hood, Apollo is going to check the props of the chat component and checks whether there is a variable that is called conversation ID available. And if so, then it uses this variable to inject it into the query right here. And this is how we know which is the right conversation to display. And so just to prove to you that when rendering the chat, we're passing the conversation ID as a prop to the chat component. Here it is. So this is how Apollo knows which is the conversation that it should fetch the messages for. The next bit of functionality that we want to implement is the ability for the user to participate in the chat and send some messages. For that, we're going to implement the onSend method down here. But the first thing that we have to do again is to create a mutation that will create a new message in our database. This is what the mutation looks like. So we're using the createMessage mutation. We're passing in the text, so that's the text that the user typed, as well as the conversation ID, so that the message can be associated with the correct conversation. And this again is the payload that we're asking for in return. Let's now use this createMessage mutation. Again, we have to wrap we have to combine our component, our chat component, with that mutation using GraphQL. And like before, we are using the compose function to do so. So first import the compose function and then adjust the export statement right here. So we're making the allMessagesQuery as well as the createMessage mutation available in the props of our chat component. Now we can go ahead and implement the onSend method. So this is pretty straightforward. We simply call the create message mutation on the props, and then we're passing in the text that the user typed and the conversation ID that we know from the props. All right, let's now go ahead and test this functionality. So navigating back to the browser, refreshing the page, and opening up the application. I'll simply open up this new chat here, type a message, hit enter, and we don't see the message appear on the screen. Well, that's kind of expected because we don't actually implement subscriptions, so real-time functionality today. That's what we're going to do next week, but we can still navigate back to the data browser to verify that our message has been created. So if we refresh the page here, we are going to see the second message to appear in the table. And in fact, if we just refresh the application right here in the browser as well, we can also see that we've got now 2 conversations, and of course we could send another we can send another message. That'll not appear on the screen, but once we refresh, we see that this new message actually exists in the database. The last bit of functionality that we're going to implement today is for the header of the chat, so the chat header component. And in fact, right here, we either want to display when this conversation has been created. So if no agent has answered so far, then we want to make sure that here we see when the conversation was initially created. But if there already is an agent that joined the conversation, then we want to show when the agent was last online, last active. All right, so let's go into the chat header component for that, and first import our GQL function so that we can write the query that we need in order to figure out that information. So here's the GQL function, and now let's send a query where we're asking for when the last message of an agent has been created. So this is what the query looks like. It takes in an agent ID as an argument, and then it's asking for that specific agent, and even more so for the last message of that agent and when that message was created. And we'll use that point in time as an indication for when the agent was last online. The way how we go about fetching the data for that query is again by using the GraphQL higher order component. So we simply import it right here, and then we use the export statement that we already saw before. Oops. Like this. So again, we're wrapping our chat header component with the last messages of current agent. But we're also passing another argument to the GraphQL higher order component. And in fact, this skip function that we can pass here can decide whether we actually want to send this query or not. Because in this particular case, we again have the situation that we are wrapping our React component with a query using the GraphQL higher order component. And the query again takes an argument. But what if, as is the case in the 2 conversations that we currently have, there isn't an agent yet that has joined a conversation? So in that particular case, we don't have an agent ID and we can't really send that query. So with the skip function, we can decide based on the props of the component whether the query should actually be sent or not. And here we make sure that we're only sending a query if the agent ID is available in the props of our component. All right, so this is basically all we have to do to fetch the data. Let's now go ahead and implement the generate header subtitle method. Here is the implementation. So basically, if we find that the query has been executed and we can receive we received the last message of the agent that is currently involved in the conversation, Then we can set the header subtitle to last active, and then the time when the agent was last active, so when they sent the last message. Or we decide that we only display that the conversation has been created at a particular point in time, and this point in time is actually passed into the component through the props. So let's save this, and also remove the export, the default export from the chat header, from the class. Move over to the application again, and if we now select a conversation, because there is no agent involved in the conversation just yet, we see that this conversation has been created 9 minutes ago. All right, that's it for today. I really hope you enjoyed learning about how you can integrate the Apollo client and send some basic queries and mutations and integrate the return data of the queries in your React components. Next week will be all about bringing real-time functionality to the app by integrating GraphQL subscriptions and actually making the messages appear on the screen without us having to refresh the page. If you want to stay informed about when we are releasing a new chapter, you can simply go to our website on graph.cool/freecom and subscribe so that you'll stay tuned when we release the new chapters. Hope to see you next week again.